John Morrissey at CSIRO eResearch. The title is Building Data Management Services Supporting a Multidisciplinary National Research Organisation. I'll just quickly go through John's biography. He's currently working in CSIRO's eResearch team in a strategic planning role, looking at how eResearch tools can be applied to CSIRO's diverse range of science disciplines. With a CSIRO career spanning nearly 30 years in various IT-related roles, ranging from building CSIRO's advanced IP network servicing all 54 sites across the organisation to establishing CSIRO's data management service. John has a unique perspective on building ICT systems supporting a major research enterprise. In recent years, John has represented CSIRO on all the technical working groups formed as part of the NCRIS Platforms for Collaboration program, and he has contributed to a number of major strategic planning documents, including the ANDS towards the Australian Data Commons. Please welcome John.
Don't you really enjoy those times when you sort of seen a previous talk and you just said 65% of the things that you'd love to say? So, there we go, how we get there. Next slide. So you get the technology going. Where is it? There we go. Yeah, hang on. It's hard to move the mouse anyway. I haven't actually got enough space to do things. Okay, this is an interesting opening slide. You know, straight from our wonderful imaging people in CSIRO, and I modified it slightly with the funny little black and white picture that you see in the middle of it there. That's actually an aerial photograph of Williamstown taken in 1937 by a researcher named Stanley Fowler. And Stanley Fowler was a fisheries researcher, and this is from the days of when CSIRO was CSIR. And Stanley actually managed to get the Air Force to sort of fly around Australia and actually take a lot of aerial photos of various sorts of parts of the coastline and things like that. And these little pieces of data we're actually finding are now actually quite useful when you're actually looking at things like how you know, the mouths of rivers have changed, historical sorts of the impact of people on the coastline, things like that. So never ever throw away old data. It's always kind of interesting. Okay, CSIRO is big and ugly. This is the standard corporate slide. 6,500 people, 55 locations all around Australia. We've had to learn to collaborate. Otherwise we don't get anything done in the organisation. We're heavy users of video conferencing and other tools to sort of work together to do interesting things. This is another one of the corporate slides that sort of that we drag out when we come to these talks, and it was what I found most interesting about it is its inaccuracy. We've just recently done a project in looking at the number of physical collections the organisation holds. We have over 55 physical collections in the organisation, of which we have about 33 biological collections. So this one here says 3 major collections is fairly dated, and it's kind of interesting from the point of view that one of the things our previous CEO said is, I'd love to know what CSIRO knows. So a lot of the driver for a lot of the development work and things like that we've done is actually around trying to create visibility for the huge amount of data we've collected over 85 years of research. So we haven't been doing this for very long. We basically started from ground zero. We had no repository. We had no drive to actually share our data. The organisation was quite happy having all its data in the top drawer. And so we basically had to start off with trying to actually teach ourselves what data management was and all that sort of stuff. And actually one of the key things that helped a lot was a trip to the UK to actually go and see things like e-prints and things like that we did with Cordit. And it was a huge sort of step up in knowledge. And I sort of encourage some of the rest of you to really have a good look around at what's happening internationally for some things like getting ideas. It's actually interesting looking at your talk, Les, about a lot of things you're talking about there is exactly what we're actually working on right now. So trying to explain sort of data management in an organisation like CSIRO, when people are actually focused on doing other things like research, is hard to do when you haven't got something to show. So you need something to demonstrate, some way, and so the very first sorts of things we did in the organisation is we actually thought, well, what's a major problem the organisation has, and how are we going to sort of deliver some sort of solution that raises our profile, gets the actual management and the scientists and everybody else in the organisation interested in e-research as a topic, data management as a topic, and actually getting some resources sent our way. So basically what we discovered is for 85 years CSIRO has been publishing stuff, and for 85 years we basically kept our own personal records of what we published. Some divisions ran Excel spreadsheets or ProSite databases on how they published various things, and every year the government would come along and say, how much stuff have you published, CSIRO? And then our 80 librarians would spend about 3 months chasing researchers saying, what did you publish this year? So we found this is a huge problem, so we basically picked that as our very first targeted bit of value to the organisation. We actually did a pretty good job of that, and now the organisation has a single system called ePublish to actually capture all the publications that happen in the organisation. Basically all this is a basic repository with a workflow over the top of it. And the one thing we did about that is we actually got an amazingly wide acceptance of the tool across the organisation, and we're able to communicate some success. The second year, well, we had the success but still no funding. And this is where I've got to say, thanks very much to ANZ for actually giving us some seed funding to take some more in-depth views of how research is done in a couple of domains. So we had our two major projects at that time. One was around water resources data management. It was looking at model predictions for water availability in the Murray-Darling. We've been doing some work for the Bureau of Met. We had to somehow get that data out to them and publish it, and there was just no platform for doing that. So ANZ came along, and we had our first project. The second one we had was around pulsar data. Now, there's probably about 300 researchers in the whole of the world that play with this stuff. It's just not a huge area of research. An awful lot of them are in China, we found out. But basically, we use these two in-depth sort of vertical slices to actually sort of look at the scientific process, look at how people work with data. What we did with our developers is we actually got them out sitting in the observatory for a couple of nights, actually seeing what a scientist does when they're actually doing observing sessions and things like that. So with these projects, we created some capability in the organisation, and we learnt about things like architecture and building a modular architecture. You can't come out and buy all the things we need straight off the shelf. I'm kind of interested in some of those things that are happening in the UK right now around Chris, so I'll be talking to you later. But what we decided to do is use a very modular approach to what we wanted to do. Metadata standards, well, you look at a Dublin core, nobody's ever going to fill in a Dublin core record. They're huge. But there are the few basic fields that everybody needs to do. So what's the minima? What do you need to work with there? And the organisation, by its nature, is multidisciplinary. So how do you make your data visible to other disciplines? All of our flagship programs rely on at least 2 or 3 disciplines to actually do anything. A classic example is the Murray-Darling project. We talk about water availability and ecology, but when you actually have, take that problem to the public, they're not interested in the ecology. They're interested in how they actually make a living and still make a sustainable living. So you need to bring in things like economic models, land use, water quality, all these sorts of things into your models to be able to actually sort of deliver a true sort of multidisciplinary answer to a lot of problems to the public. And again, with both these projects, we communicated our success. We had a bit more success this time. We actually won a CSIRO award, which is very rare for a development team to actually win this in the organisation. The scientists actually in the pulsar area thought so much of the project and the outcomes that they actually put us up for a CSIRO award. So, multidisciplinary data model. Okay, this is going on from some of the things that Les was talking about. The process of science. We use the core scientific metadata model because it talks about concepts like the experiment or and some of the actual processes of actually doing research. And so if you use that as a base model, what you can do is actually start bringing in things like your research management systems. So, in CSIRO we use SAP as a project management system. Projects are described in various systems. We need to link those into our data model so that what the eventual thing we want to end up with is when a project's approved in CSIRO, some data spaces are created, metadata is already preloaded in there about what the project's all about, and the linkages, we start building linkages in the final system. So we use the core scientific metadata model as a base layer, and we've developed a bit of code around what we call a data aggregator. And basically, whatever version of data we poke into the system, this software tool generates other versions. So it generates a Dublin core version of it. It generates RIF-CS metadata records about collections. So we don't, and it automatically does that out of the initial piece of data you deposit. So we try to automate a lot of that at the time. Now, the other interesting thing about this model is that with all your data models, you're going to serve a lot of different communities. So, for instance, with RIF-CS, that's the general outside world, what collections does CSIRO have? It's the public, what collections does CSIRO have? For the enterprise, they want to know what research the organisation does, to answer our previous CEO's sort of desire. The research domain. Okay, we have collection level, fairly broad, business level, a bit more detail, and then every domain always wants to have more detail about their particular area. You've got to be able to cope with whatever metadata that they want to provide you and create some sort of search environment for that. And then we basically automatically cross-reference that stuff with other metadata standards. Okay, here's the obligatory architecture picture. Main thing to get out of this is that everything's modular. So, at the moment we've got a Fedora-based repository in the middle. Something better comes along, we can take that out and transfer the data and put it somewhere else until it gets too big. But basically, what we've got the dataset metadata collector, which is this little piece of software that I've talked about that does the mapping between all the metadata standards. We have a data access portal. Now, that's sort of like an enterprise view of our data. We have a philosophy of, okay, we've got to provide some solutions for our people and people who want to see a CSIRO view of things, but we also make sure that we get as much of our data out to as many community portals as humanly possible. So everything is harvestable. People are going to want to have different views. People have different thoughts about what a collection should contain. So basically, we're going to make our data as open as possible to all the research communities, no matter what sort of domain you're in. But you still have to have the capability of building specialised search. I mean, when you look at the astronomy area, like geospatial searches, bounding boxes and things like that, in astronomy they use cones. So you've got a point of origin and a cone in the part of the sky that you're actually doing a survey of. So, the search tools we built for that are totally different. And you have to have that capability to be able to add those things into your base model all the time. Eventually, you need to be able to develop the capability of capturing metadata as people do research. So, moving on from here, we're going to be moving more into as you do things, we will build information about that. It may be a combination of using electronic lab notebooks. It may be a combination of capturing events as people interact with ICT platforms. A lot of it's still the next sorts of things that we need to actually build in our environment. So basically, the whole aim is to there are not enough people to here's my data, take care of it for me. We have to have a self deposit capability. Researchers have to have their own view of their own data. They have to have a community view of their own data. and they have to be able, they need to be able to take that with them sometimes, because sometimes they actually leave the organisation. The effects of actually doing a lot of this sort of stuff, it's been interesting. People say, why do I want to share my data? We've actually been able to demonstrate some really major benefits of doing this. Like I said, with the Pulsar data project, it was a project that wasn't actually going very far, not a lot of citations. As soon as we published the data, we had over 20,000 hits on our web page, and so far I think they've dragged about 5 to 6 terabytes of downloads off the data access portal in that particular area. Now, for that fairly small part of science, it's actually kind of a big thing. So out of that, there was immediately more collaboration with our scientists, with other scientists, because they had the citation of the data. The observer's name went with the data, and then the people who downloaded the data then contacted, and then new collaborations came out of that. So the scientists actually saw immediate benefits from sharing. So data, this is probably a slide that those of you who went to John Taylor's talk will have seen around the sorts of services that we're offering as an enterprise service in our e-research area. In every one of these domains, the planning, there is a role for planning for your data management for projects. In the collaboration, we have new and emerging environments that are very rich data environments. That, for instance, in OWL, when you do the analysis of the prize racehorse that's just been bitten by a bat, and you're about to go and shoot this thing, they're fairly significant investment. So the decision about what disease that horse has, doesn't have Hendra, is actually something that we actually have to capture the provenance of. So some of these the video collaboration environments and things like that, we actually do collect these sort of more significant data sets of different forms and things. So basically, right across the whole flow of research, data is important, and it's approached in different ways in our e-research framework. Okay, current development activities. As I said, it's not practical to channel all your data through the library. It's just not going to happen. There's not enough people there. Our data management group actually has a role in quality, but not in doing processing of things. We're looking at the current tool. We've done the domain projects in water and astronomy. We're now actually working on a generic tool right across the whole organisation that allows everybody to self-deposit using a basic workflow. Now, we're a big government organisation, and people do expect a certain amount of bureaucracy as you're actually loading data. We do try to make that as easy as possible with the interfaces that we're building. So, for instance, all of the data about the researcher is actually dragged out of our Active Directory system. As soon as you log into the system, it's pre-populated in the data forms when you do your deposit. If you do a lot of deposit in an area that you commonly use, a lot of the fields are already configured, and you just have to select whether that field's still appropriate to the data you're depositing. So we try to actually lower the effort of actually doing the data deposit at the moment. We expect to have a production release end of this month, next month. There's the head developer over there, and we'll be doing formal training for probably about 3 months into the new year. It was interesting. I was having a chat with a couple of people about, why haven't we done the big flash thing? You've got to actually be able to give people somewhere to put data. You've got to make it easy for people to put data somewhere. At the moment, it's much easier to leave things in the top drawer. So we just want to give this capability to everybody in the organisation. Storage. Storage is interesting when you get to a petabyte. Backups don't work, and you have to use different ways of actually managing your storage. So in our repository, what we're actually doing is getting people to build collections of data. We then take those collections, put them in a container, compress them, and then that container is the file that goes into the storage. And you might put 2 or 3 copies of this around as checksums. Basically, we work on the theory of, well, send a number of copies around. If the checksum doesn't match, we'll go and find one that does match, replace the original copy. We won't be doing backups of petabyte repository stores. So we're having to work on new and interesting ways of sort of making sure that the data stays there for a long time. Sensor networks and real-time processing are a real challenge. We're now having our researchers approach us now and going, okay, as the data comes off the sensor, I want to be able to run my model straight away, but you've got to capture it, and I want all this sort of stuff in the long-term store, and I want monthly things and all sort of stuff. So the time to actually process things and put them in a repository is sort of a limiting factor about how you actually do real-time data management and data processing. You've got to be a little bit creative about how you actually build those sorts of systems. So we're doing some research projects at the moment with the sensor network people to actually see how we can actually do the deposit into a repository or into some storage, or how you actually design that sort of system. So that's one of the kind of things. Last sort of thing, to actually sort of be able to talk about bits and pieces, you've actually got to go every now and then have a really good hard look at the organisation. We actually went and got a professional report done. We went out to the whole organisation and did a survey of scientists, librarians, everybody that we could sort of think of to talk about the data management. And we've developed sort of a 5-year strategic plan and a roadmap of the sorts of things we want to do. If you're interested in what CSIRO is going to do, how it's going to do that over the next 5 years, what the issues we've came across in our organisation, send me an email and I'll send you a PDF of what this document's all about. It's an interesting read. So, key points: communicate often. Make it easier. It's easier to sell a concept if you've got something to demonstrate. Don't talk about vaporware. You'll never get anywhere. Agile development really worked well for us. But in agile development, what we did is we actually made sure our developers actually got to experience some of the science. We made them sit in the labs and actually sort of see, what do you guys do and how do you actually do things? Be driven by the science requirements, not by your own ICT type desires to do things. Automate as much as possible, because you've got to really lower the barrier to work with these systems and celebrate your successes. That's pretty much basically it. Here's a few useful links that will be available later on. Any code we're developing, we're making available open source. It's very well documented stuff. It's been through unit testing. So we can pretty much guarantee it's actually pretty good quality stuff. Thanks to my friend over there. And we're, unlike a lot of other areas, we're actually eager to share this stuff. So if you want to have a look at some of our software, if you want to look at things like metadata models up there, that's basically it. Want to ask us some more questions, come to our stand. We'll show you the ePublish and maybe the data access portal. And that's me.